Welcome to The Explainer. Today, we're talking about a massive revolution that's being triggered by the AI boom. But it's not happening in code or on a screen. Nope, this one is all about steel, concrete, and power lines. So, what do you think really fuels AI? The first things that come to mind are probably data, or maybe those super complex algorithms, right? But the actual fuel, the one that's forcing this huge global shift right now, well, it's way more fundamental than that. It's power, just incredible, unprecedented amounts of it. And this insatiable hunger for energy, that's the real story here. This isn't some far-off prediction, it's a full-blown revolution happening today, and it is literally reshaping our physical world as we speak. Okay, so let's get right into the heart of this. Think about it. Every single time you use a generative AI, you're tapping into a system that is pushing our entire global digital infrastructure right to its breaking point. And this is what we're calling the 2026 data center energy revolution. And again, this isn't some theory, it's today's reality. It's this epic collision between AI's explosive growth and the very real, very physical limitations of our power grids. In this new world, access to raw power is now the single most important factor for technology's growth. So, what happens when a force moving at the speed of light, that's digital innovation, slams into an object that can barely move an inch? I'm talking about our aging power infrastructure. Well, what you get is a crisis. And out of that crisis, you get a revolution. And the problem really starts small, right down at the chip level. You see, every single new generation of AI chip, the very thing that makes AI smarter and faster, is also way, way more power hungry. We're talking anywhere from 3 to 10 times more power for just a single chip. That's just wild. And this right here, this shows you the core conflict perfectly. On one side, you have AI's demand for power just shooting for the moon. It's growing exponentially. But on the other, our public power grid is growing so slowly that it can take 5 to 7 years just to get a new data center connected. That gap is completely unsustainable. So, this collision is forcing a radical pivot. For decades, we built the internet close to people in cities to cut down on lag time. Now, the tech giants have stopped chasing proximity and have started chasing raw, consistent power wherever they can find it. So here's what this new playbook looks like. A tech giant needs a massive new AI facility. They check with the public grid and find out there's a 7-year wait, so they pivot. They stop looking for land near cities and start looking for land near power. They might even commit to funding their own on-site nuclear reactor. And that means a complete overhaul of the data center design to handle radical liquid cooling. This is a total reversal of how we've built the internet for the past 30 years. And this pivot isn't just about location, it's about the design itself. Remember those new AI chips? They get so incredibly hot that the old way of cooling servers with giant air conditioning units just doesn't work anymore. The heat density is just way too high. The solution sounds like something straight out of science fiction. It's called immersion cooling. We're talking about taking entire server racks and literally dunking them into tanks of a specialized liquid that doesn't conduct electricity. It captures nearly all of the heat, and it's quickly becoming the new standard for any large-scale AI facility. So when you combine this chase for power with these totally new cooling designs, you get something pretty profound, a completely new geography for the internet. The digital map is being redrawn, not by population centers, but by energy sources. And this table just lays it all out, the old versus the new. The key metric used to be latency. Now it's all about watts. The hubs used to be cities, now they're rural sites right next to power plants. The energy source is shifting from the public grid to on-site reactors, and cooling is going from air to liquid. The big takeaway is this: digital infrastructure is no longer being built near you, it's being built where the power is. But look, this massive and incredibly fast revolution isn't just a simple story of progress. It comes with some really significant risks and very real costs for all of us, not just the tech companies building these things. You see, there's a critical mismatch here. The demand for all this power is exploding right now, but the new nuclear power sources needed to actually meet that demand, they won't be ready for several years. This creates a really dangerous vulnerability gap, and it's being strained by supply chain bottlenecks for everything from transformers to liquid cooling parts. And what's really important to understand is how this could directly impact your daily life. This huge power draw could drive up your electricity prices. The cooling systems can put a massive strain on water resources. And the sheer load could cause local grid instability, potential brownouts.
These are real, cascading risks that we are only just beginning to deal with. So, when you boil it all down, this shift is fundamentally reshaping our physical world, our energy infrastructure, our land, our resources, all to serve the needs of our digital one. And it leaves us with one final, crucial question to think about. We are building this incredible new world for AI, but are we, as humans, prepared to live in it?